Hello and welcome everybody on this warm and sunny afternoon to the latest in the series of webinars from UKSPA. This one's Creating Sustainable Life Science and Research Facilities. How ready are you? So over a quarter of global CO2 emissions comes from the built environment. So the global community really needs to start reducing building energy consumption, probably by over 80% to reach zero carbon targets. So today we're going to hear from UKSPA Network on how we can and must take radical steps on the journey to securing a net zero legacy. We're currently being joined by delegates, so we're going to start in a minute or two, but just as always, all UKSPA events are very much interactive, so please do feel free to put forward questions either through the Q&A function or if you want to make comments through the chat. We'll pick up on those and we'll make sure we address them. So we'll pause for a little while just to ensure everybody's here and then we'll start. Okay, so I think we're good to go. So I'll just say welcome again for those that are late joiners. So today we're going to be talking about creating sustainable life science and research facilities and how ready we are. For those of you that don't know me, my name's James Chaffer. I'm the Operations Director for University of Nottingham Innovation Park, which you can see behind me. So I don't claim to be an expert in this area of carbon reduction, although I do seem to be effortlessly floating above the GSK Zero Carbon Sustainable Chemistry building, which you can see on that side. So that's my claim for today, but this can be a learning experience for me as well. So we've got three excellent speakers lined up. Each of them are going to speak for approximately 15 minutes or so, and then we'll look to take questions afterwards, and then there will be time at the end for a more detailed discussion and Q&A session, where hopefully we can get some interaction, some debate going. So as I said at the beginning, please do feel free to put forward questions through the Q&A, and we'll pick up on those either at the end of the presentation or at the end of the session if we can. So without further ado, I'll introduce our first speaker. So firstly, we have Carl Potter, who is Managing Director and Principal at Avison Young Birmingham. So Carl's going to be talking about sustainability from a property perspective. Carl's Avison Young Principal and Managing Director of Avison Young's Birmingham office. They specialise in development consultancy transactions and has been involved in some of the leading regeneration and new development projects across the region, including Pedimore, Birmingham Life Science Campus, Birmingham Business Park, Loughborough University Science and Enterprise Park, Malvern Hills Science Park, Innovation Birmingham Campus, and the recently completed Eastside Locks development. So I'm going to hand over to Carl. Carl does have a commitment to the end of this, so we will aim to take questions at the end of Carl's session if the time is permitting. Otherwise, I will hand on to Carl to start his presentation.
Thank you, and hopefully my screen is sharing correctly. I'm Carl Potter. I'm Managing Director of Avison Young's Birmingham office, and I'm very pleased to have been asked today to present on a very important aspect of science park development. And really, this is something that sits very well with Avison Young's purpose-driven approach. I think without doubt, the pandemic has accelerated trends in real estate, and not least the science park and the life sciences real estate sectors. It's altered occupiers and investors' outlooks, and as we seek to build back better, it's further increased the importance placed on environmental, social and governance, or ESG credentials. And these aren't any longer a nice to have. The climate change emergency has heightened awareness across the science park sector, and owners, occupiers, investors and developers are all now being compelled to take steps on the journey to securing a net zero legacy for the spaces that are pivotal to the UK's innovation and growth agendas. And I think there's now clear, tangible opportunities available through commitments to ESG, including green financing, enhanced yield and rental returns, and tenant retention. I think these are all part of the mix of making a successful science park. And we're thinking, as we move forward, these are going to be a really important aspect of that. So the refocusing of ESG towards health and well-being is also increasingly evident from occupiers as they work towards the recovery phase. Today we're going to consider how we measure broad sustainability attributes, how this differs from energy efficiency, the emergence of ESG and impact funding, and how health and well-being are both assessed and why. And then before looking forward to where we will need to be in the future. And as James mentioned earlier, that drive towards either net zero carbon or zero carbon itself. So BREEAM was the first UK rating system to assess and certify the sustainability of commercial and non-commercial buildings. It was introduced in 1990 and it's now been in place for over 30 years, and it's evolved as sustainability criteria has been refocused. I think it's fair to say that many science parks have now been developed to meet specific BREEAM standards, and this has been pushed in particular where there's been public sector ownership or involvement within science parks for a period of years. First phase at Portland Science Park, which we can see here, was being developed and owned by Wiltshire County Council, and that scored a BREEAM very good. And whilst phase 2 will in part hit excellent, I think it's fair to say that there are challenges with science parks, particularly where they're speculatively developed, where they include laboratory space, and where the owners and developers aren't actually sure how the buildings are going to be occupied. A lot of BREEAM assessments are done at design stage. It is possible to then go back afterwards and look at that. But when you're trying to hit BREEAM as a design, it's quite difficult to forward predict. In terms of building stock, just to give you some measure, around about 1% of BREEAM testing meets outstanding, and only around about 5% of the stock hits the excellent level. So those are very, very hard, difficult ratings to achieve. BREEAM does now sit alongside its US equivalent LEED, and both do continue to provide a well-regarded rating method, taking into account a broad range of factors. And whilst in the UK it's more common to certify buildings on the basis of BREEAM, the extent to which US investors and US occupiers who are significantly active in the UK science park sector, they often require the undertaking of LEED assessments before committing to space, particularly when the building is designed for their occupation, either a pre-let or a turnkey solution. There's also been a legal requirement since 2008 in England and Wales, 2009 in Scotland, for energy performance certificates to be in place when a building is either sold or rented. And similarly, you'll be aware that public buildings require display energy certificates, which are very, very similar. So this is a mandatory or imposed regime, unlike BREEAM or LEED. And we're moving now towards a position of MEES, which is the minimum energy efficient standards. Those regulations came into effect in 2018, effectively forbidding the leasing of premises which are not able to achieve a minimum of E. And these requirements are going to be tightened further in April 2023. And the government has announced its intention to raise the minimum standard required to B in 2030. So that's going to put an enormous amount of pressure on existing stock. And that, in our view, will have two effects. Firstly, putting pressure on building owners to upgrade their buildings to be more energy efficient. Secondly, to remove poorer quality buildings from the market. And we know that that has a positive impact on rental values as we move through property cycles. So as you can see, the impacts of those are fairly significant. The equally important question, however, is what do investors and occupiers want? And I think it's fair to say that whilst the first moves towards sustainable buildings emanated from the occupiers of buildings, there's been a notable switch in the emphasis of direction, with funders and owners of science parks moving strongly towards achieving greater sustainability. And this is not just a box ticking exercise, it's a clear mission to contribute to a greener built environment. A number of impact funds have been involved, targeting not just investments that will have social value credentials such as affordable housing, but those that contribute to the environmental challenges we also face. So similarly, in some instances, lenders will not consider just the value of a building in the current market, but how the energy performance of a building is likely to impact its future value. The introduction of social impact bonds or green bonds, we think could be increasingly used within the science park sector to fuel economic growth. That's a funding model which compels developments to go above and beyond traditional sustainability requirements in order to future-proof both rental values and capital appreciation.
In terms of the big units available, we've got the Argos upstairs and this one down on the right.
As the importance of social value permeates every aspect of corporate life, sustainability will sit alongside other aspects of ESG touched upon by the built environment. So the pandemic has fueled a greater understanding of the need to consider the mental, physical and emotional health impact of the buildings we spend the majority of our working hours in. I think the war for talent, which occupiers faced, has highlighted the need for existing and future science park developments to be right at the forefront of ESG, as people entering the job market now expect to work within healthy and sustainable environments. There are several tools and standards available for occupiers and investors to ensure well-being and health impacts can be monitored. I think the first of those that was introduced was the Well Building Standard, and this is a performance-based system for measuring, monitoring and certifying the impact that buildings have upon human health and well-being through air, water, nourishment, light, fitness, comfort and mind, and those are now an internationally recognised accreditation. There are alternatives coming into the market. There's things like Reset and Fit Well, which demonstrate health and well-being lie at the heart of an occupier's desire to maintain staff retention. And this also, it's not all altruistic. There's an ability through these systems to boost productivity and reduce hours through ill health. And where we see occupiers seeking to retain staff of an older age, obviously the wellness of those staff members are very, very important. And the ability of the built environment to influence their health, their well-being and their physical capabilities going forward is really important. I think it's fair to say many occupiers are now keen to push the envelope much further and signing up to science-based targets, Race to Zero, and other initiatives that seek to accelerate that change. Many occupiers are, to an extent, being forced into an arm race of sorts between businesses and within sectors. And there's no doubt that both occupiers and investors will be driven to net carbon zero targets, with a number of businesses seeking to achieve this milestone by 2030, 2040. I think Avis and Young ourselves have put forward a commitment to become net zero carbon in our operations by 2030. Others may accelerate that, others may push that out. But by I think 2040, this will be very commonplace. And this does pose a significant challenge for building owners and occupiers with energy intensive buildings. Existing laboratories often have particularly high energy requirements. So the journey to net zero carbon has to be really well prepared and the route planned out. I think this also has to be compared with a true carbon zero approach, which a number of our public sector clients are looking at, local authorities, universities are keen to pursue. And particularly from a local authority perspective, this is about them putting themselves forward as an example of how they want other developments in their area, in their local authority or in their county to be pursued. So in conclusion, all of these considerations will need to go hand in hand with more classic sustainability driven design to provide assets that deliver on all fronts. Poor design, inadequate specification, all will be costly in the future when just against a building's medium and long-term performance. Going the extra mile may soon become the norm to ensure our buildings meet occupier, developer and lender demands for sustainability. And whilst this rings true right across the property industry, Science Park's ambitions to be at the forefront of this, I think, is embedded into their DNA. They are, after all, the spaces that are driven by people who seek to inspire innovation. Thank you very much for listening. That concludes what I want to talk about. As James said earlier, I am unfortunately needing to leave prior to the end of the seminar. So if there are any questions, I have been asked to take those now. Thank you very much.
Thank you very much, Carl. That was really interesting. Learned a few things already, so that's always good. We do have one question that's come through on the Q&A so far. If anybody else wants to ask a question, please do so. But we've got a question from Luis, who's asking, what do you think about the Green Finance Institution Coalition and the idea of green leasing agreements?
So green leasing agreements or green leases have been with us for a long time. They have been fairly unsuccessful to date in that it was almost a compulsion on parties to act in one way or another. But the commitment, I think, now from an occupier and a landlord are seen as dual commitments and not necessarily needing to be driven into a lease per se. It does fetter what an occupier can do, and we know that when you get to lawyers and you start looking at lease agreements, they tend to move back to what is more traditional and objective rather than what clients may be compelled. So there is an air of caution around those. But in terms of Green Finance Institution Coalition, that is obviously something that is a good way forward. And as I said earlier, lenders, the rise of social impact bonds and the rise of impact funds themselves are going to be really, really influential going forward.
Okay, great. I'm not seeing any other questions on either the chat or the Q&A. Luis says, thank you very much for that. So that's good.
Quite all right.
Answered that question. That's perfect. I'm interested, Carl, from the kind of wellness perspective. And so you mentioned the well building standard and a few other sort of emerging standards. That's something that I'm sort of starting to hear a lot more about, and particularly trying to look at whether we can sort of apply those to existing buildings. Do you think there are things that can be done with existing buildings rather than just purely concentrating on new buildings?
Yeah, and a lot of the WELL standards is about the fit out and the internal part. So it's how an occupier, it really is driven by occupiers. And this goes down to things like really mundane things like what you use to clean the desks and cleaning fluids. If you get those wrong, you start to harm the air quality. Wellness it's a lot about the level of air that's introduced into a building. Now, the standards for that have risen during the pandemic because we need to be cleaning our air as it goes through, but also the quality of that air. And the quality of the air within a building is driven by a number of factors. There's one eminent engineering consultancy who about 3 years ago started to look at the WELL standard in their own buildings, and they couldn't understand what it was that was harming some of the air that they were seeing, the reading and the results they were getting through. And it was purely down to the cleaning products. And you start to take those out and you start to use more environmentally friendly products and you start to get where you want. So you've got to go right the way through your supply chain. Who cleans your buildings? Who does your maintenance and all that sort of stuff? But it's a really interesting aspect of the building. We were involved years and years ago with Warwickshire County Council on a building that they wanted to commit to being green. So they went through a non-traditional air conditioning system, comfort cooling system. And they found in that building that by 4 o'clock in the afternoon, everybody was still vibrant. Whereas the people who'd worked previously for the company, by 4, they'd been flagging by a traditional VAV air conditioning system. So these things do impact quite severely on how much energy you have by the end of the day.
Interesting. We've got one more question if you've got time still, Carl. We've got one more question coming through. So Scott Anderson's just making a point. So he says, very pertinent point on BREEAM versus LEED, given the interest in the American market. Can you give us an impression of the level of compatibility between the two assessment types and any major differences, and perhaps the sort of costs involved in proving to an American interest that the building meets their standards?
Yeah, so BREEAM is tried and tested massively in the UK, and the cost of the BREEAM assessment it's been driven down as a consequence of that, and the number of people in the market can provide them. LEED is far more specialised. There are less assessors, and therefore there's always a cost that comes with that. And of course, if you're designing a building in the UK that's for multi-occupancy, you may be driven to doing BREEAM and LEED. So it's more than double the cost of BREEAM. The differences are, there's not a significant difference. They all measure a broad range of attributes, and I think it's fair to say that each of those have probably learned from each other over the years. So they're not static, they evolve, and what they test today in this market will be different from what was tested 5 years ago and 10 years ago, etc. So there is an interaction between those, but there are some slight differences, but not an awful lot. It is about getting the accreditation there. That's a really important point.
Brilliant. Okay, thank you very much. Actually, I'm now starting to see some bits coming through on the chat that we might need to pick up later on. I think to keep time, Carl, we'll stop there. But thank you very much for your input and participation. That's very much appreciated. I think
thank you, James.
Some good points there. Okay, so next we're going to move on to our second speaker, Debbie Hobbs. So Debbie is the Group Director for Sustainable Business at ISG. Debbie joined ISG in April 2019 and manages a team of 35 dedicated sustainability and social value experts within the construction industry. She's passionate about delivering net zero carbon buildings in operation, which use sustainable materials and add value to a local community. She's also worked previously as a consultant, client, contractor, and energy manager for a local authority. So it gives a unique insight to the workings and contractual challenges of buildings worldwide. So I'll hand over to Debbie. Where you go.
Thanks, James. Just checking you can hear me okay.
Yeah, hear you and see you fine.
See you, good. Thank you. Hi, everyone. Yeah, I've worked in sustainability just about from every angle over the last 35 years. And that was a really good introduction of where sustainability's been and what kind of levels we're looking at the moment. As James said, I'm the Group Director of Sustainable Business at ISG. I manage a team of 40 specialists in-house. We do have both BREEAM and LEED assessors, and we've looked at the wells. We have well assessors in-house as well. And we've spent a lot of time over the past few years trying to get badges to put on buildings. Prior to ISG, I came from legal and general investment management and the real estate arm. So I was very much looking at investors' interests in investing in our funds and the value of buildings going forward. And yes, it's important to have these badges like BREEAM and LEED because it's the only way when you're buying and selling property, you've got any kind of idea what the property was designed to do. But I think we're moving to a new era. We're moving to the era which is about how a building actually performs in practice. So not what badge it was given during a design process, design standard, but how is it performing in practice? So I'm just going to start by reviewing sustainability and pretty much just going over what we've just said. So at the moment, everybody is talking about being carbon neutral, net zero carbon or zero carbon. When I ask clients what it is they mean by that, and then how they're going to get there, that's when I always get somebody go, oh, yes, that's a really good question. We don't really know. We've made a commitment, but we're not really sure. So I'm going to show you in the next few slides the kind of processes, the costs and the barriers of how we need, what we need to get through to actually get there. And it's really not going to be easy. It's not as easy as having a BREEAM badge on your building or a LEED badge or even well. It's also driven a lot by investors, as I've said. In my previous role, we did a lot of work looking at the investor angles like TCFD, and investors are putting more and more pressure on property funds and big corporates they invest in to prove their environmental credentials. So as a company, ISG, we're looking at, we set our own environmental, social and governance structures, and we're having to report on to our clients as we build and refurbish buildings. When we come to our projects that we do with clients across all buildings, we get asked now for a myriad of services, depending on who the client is, the market they're in, the investors they've got. They will be looking at any of these areas that I've put up here and all the different nuances in them, depending on whether they're more focused on carbon in operation, carbon in the materials we're using, whether they're into social value and community aspects around their site, or whether they're really looking into the future and they're interested in the materials in terms of circular economy. So can we use materials that don't need to be even recycled? Can we just make them so that they can always be reused? And can we build buildings that can be constructed using designing for manufacturing assembly, but also for disassembly? So particularly in the area of parks, and I put anything from a retail park and a shared and science parks into the area of parks, can we build buildings that can be constructed and deconstructed so that no material is wasted? So there is a massive challenge going forward. We've also got to be compliant. And then finally, we've got to pay really careful attention to how the buildings operate in practice. So it's a challenge these days. It's a massive challenge. But I'm going to focus in a little bit more detail on carbon, because that's the one that everybody at the moment is really talking about. Everybody's made a commitment to get to net zero carbon. And as we've heard earlier, there are now a number of signals for legislation that are going to come in to prevent buildings being sold or being let if they don't meet a certain energy efficiency target. On top of that, there is this definition of net zero. Now, some people believe that if they make their building all electric and buy a renewable energy tariff, which is from the electricity grid, which in the future will be on renewables, that counts as net zero. Well, the bad news is it doesn't. It just means that you are buying a renewable tariff and you might be carbon neutral, i.e. you're not causing any carbon to be generated. But in order to call yourself net zero carbon, you have to look at the definitions. This one here from the UKGBC, and the work done by the UK Green Building Council has looked at what future renewables we might get on the grid by 2050. So by 2050, the orange line is showing that we'll get, say, 374 terawatt hours of energy onto the grid, which will be renewables and a little bit of nuclear that we've got remaining on the grid by then. But it won't be generated by any fossil fuels. The pink line, however, is the demand of energy. So at the moment, we are using 944 terawatt hours of energy. Doesn't matter if you don't understand exact units, but we've got to get down to 374. So every building in the UK has to reduce its energy consumption by at least this amount. The bad news is it's not just this 60% reduction you see here, because we've also got to add transport onto the grid. So all transport, all cars will have to be electric, and process energy. So any energy that's used within a building for a process, or in the case of Science Park, the labs, the actual work you're doing in the labs uses a lot of energy. All that has to come from renewables. So for buildings alone, we need about an 80% reduction in the current level of energy used in our buildings. And when you get your head around that, it is massive. I'm just going to explain a bit more about where the challenge lies. Currently, we know that buildings use, on average, 284 kilowatt hours per metre square per year. We did some research as ISG recently on called the Sustainable Building Monitor, and we looked at all commercial floor space from the valuations database, and we looked at the energy use of commercial buildings in each region of the UK, and we looked at what the average kilowatt hours per metre squared was for all commercial buildings, and it's roughly 284. To get from 284 down to 55, which is the definition of net zero before you buy renewables from the grid, is very difficult. Good operation and actual maintenance, paying for good maintenance, not tendering to a minimum price where you barely get maintenance, will get you some of the way. If you strip out the building when a tenant leaves and you put in new HVAC and new fit out, again, the best I ever got at Legal & General, changing boilers, chillers and air conditioning, was down to about 100. And across the industry, across CIBSE, I'm a member of CIBSE, we don't know of any buildings that have got to below 100 without a refurbishment right back to the fabric. So to get to this level of net zero, you have to strip buildings back to the bare fabric and structure, have very, very tight U values, very tight, very good air tightness, and also look really carefully at your thermal bridging. Even then, you've got to then operate it properly. And the big question is, what if you've got a building that you can't do that to? You can't achieve that kind of level of air tightness or U values, or the cost is so prohibitive. Perhaps you'd have to have opening windows, which is pretty much going to be the requirement to get to this value. And you've got a cladding that you just can't put opening windows in. If you've got to reclad the building, you've got to take the structure down. However, then you've got to decide, do you want to demolish or refurb? And you've got to consider the embodied carbon. Because at the moment, the GLC are already putting embodied carbon targets into planning. So you won't be able to build a building unless it meets certain requirements for the embodied carbon, which is basically the energy and carbon used in transporting materials to site. Now, at the moment, it's just a target and it's achievable with the materials we have. Going forward, I suspect there's going to be a cost to that embodied carbon. So the cost of that embodied carbon will slowly ramp up to the point where if you're going to build a new building, it's really got to be for a specific reason. The value of that material in the economy will be given its true value to our climate and our environment, not just the cost of getting it out the ground or the mining going forward. Again, that will make building very prohibitive. So you have to look at the whole process to see whether a building performs going forward. Yes, the design, the construction, the commissioning, but the leasing, then you've got to be careful on fit out loads, are tenants moving in with their own renewables, how are you going to commission all that? And most importantly, from my experience of running big property portfolios, who's operating the building? Is it the landlord or is it the tenant? And who in the tenant's team is responsible for the day-to-day operation? Not the maintenance done by a maintenance contractor, like when you take your car to the garage, but who's driving the car? Who's setting the time clocks every day, checking the temperatures are right, checking that the energy is being used properly? Doesn't really happen very much. So we've developed a system when we're building net zero carbon buildings now at ISG, we're looking at a system called Performing Places. This basically takes the design model, links it with the BMS and the construction information, and ideally the planned maintenance plans, and then starts monitoring if it's performing in practice to how it was designed. Because even if you've got a net zero carbon building handed over on paper, and coming out later in the year, there will be certification for this, how do you know it's going to be operated to a net zero carbon level and somebody's not going to leave the lights on? Quite simply leave the heating on, put in new meeting rooms and add in energy efficient, and inefficient air conditioning. So it's a big challenge. And just to give you an idea, this is a building we've been monitoring 2 years after we completed it. We just went back to do some monitoring. And this is something that's been happening during COVID. This was its prediction on the left. And this is not unusual. Most buildings perform 4 or 5 times at least more than the model. But what you can see here is this green layer is what they call fan pumps and controls. And in operation at the moment, this is how much the fans and pumps are using. And the reason this is somebody's decided to leave all the air handling on 24/7 because of COVID. And this building also has chilled ceilings and the controls aren't working. So what they're doing is they're heating air up to cool it down again to remove the humidity so that the chilled ceilings operate correctly. And this is not untypical. All buildings I've ever met that were being managed by managing agents operate in this kind of fashion. Nobody really looks at the way they're being controlled. And unless you really monitor it carefully, it's going to be really difficult to achieve this operational accreditation going forward. And my final thoughts here are, with all the people that are involved in managing a commercial building, are we really going to get there without regulation and inevitably more costs? Because we've got a whole myriad of people, from the owners, the fund managers, the managing agents, then the occupiers and their staff, then the lawyers and the valuers who get involved, the lawyers who draw up the contracts and the leases, never yet met a tenant who's going to commit in a lease to achieving net zero in operation, especially if it's going to cost them anything. And then you've got the owners, building operators and management company, and all those people have to work together to achieve net zero, and somebody's got to pay for it. And yes, there's green funds coming up, but does anybody really understand the cost of this? With our Sustainable Buildings Monitor, we did a little bit of work and we looked at all the commercial floor space. And from some of the refurbs we're doing, let's just say it costs 2k per square metre of floor space for the whole of the UK. We've got 10,300 days to do it to get to this target. But that would cost 1 trillion over the next 30 years if we're going to get to net zero in our buildings. 1.2 trillion pound, which, if I did my maths right, was roughly 340 billion a year to refurbish our buildings. Good news for us, because we're one of the UK's premier fit-out companies and we do a lot of refurbishment. But that kind of value of money, I can't see coming from anywhere. So when people tell me they've committed to be net zero carbon, I just look at them and start asking some questions and think, it's all words at the moment. What are you going to do tomorrow and in these next 10,000 days to make sure your buildings get to net zero? So I just wanted to share that with you. It's my current challenge to the market. If you're serious about net zero, start looking at how you refurbish your buildings. Start with the fabric. Don't change to heat pumps, air source heat pumps, until you've done your fabric. Because if you change to heat pumps first, you oversize the heat pump, cost you more, and to run a heat pump at part load is really inefficient. So again, you won't achieve that stamp of net zero in operation. So I'll leave you with that. I'll see if we're having questions now or later, but thank you very much for listening. Back to you, James.
Thank you very much, Debbie. That was, I was going to say, that's interesting. It's actually quite scary when you start looking at the numbers. I think we're probably all gulping a little bit at this point and wondering where we're going to get all that money from. But I think it's really good to do that analysis and actually see the impact, the financial impact that's going to be required. We have a couple of questions that have come through that we might save to the end. There was a quick one that I might just pop in now, which is from Rob Partridge. So he was asking if there's any guidance on embodied carbon targets for labs.
That's a really good one. Probably the answer is no. There's a lot of work going on in embodied carbon. It depends on whether you're refurbishing a building or building a new building. There's a group called LETI, the London Energy Transformation Initiative, LETI, which if you Google it, it's all free documents online, which was a group of about 30 or 40 of us professionals around London initially, but around the UK, who helped develop a guide on how you would ideally build and design and develop a net zero carbon building. And it's got embodied carbon targets in it. There's now a discussion going on with LETI, the UKGBC, RICS and CIBSE to see if we can come up with targets for different types of buildings. But to be honest, to me, the embodied carbon is secondary to getting buildings operating in practice. Because in a net zero carbon world where nobody's using fossil fuels, yes, there won't be as much energy around, but every material will be zero carbon. There won't be any embodied carbon because nobody can use fossil fuels. But great question, thank you.
Brilliant, thank you, Debbie. So I'd say we'll come back to the end with some more questions we've got, but we'll move on now to our last but not least final speaker, Keith Pepper, Architect Director at BDP. I'll get my tongue in place. So he's going to talk about a sustainable approach for innovation places. So Keith's head of science, research and technology across BDP and has played a leading role on a wide range of projects of different scales, including schools, higher education and research buildings. He specialises in briefing, design and delivery of sustainable science research buildings and espouses collaborative working with clients at the cutting edge of research and technology to foster and inspire world-class discovery. Sounds fantastic. Keith, over to you.
Excellent, thank you very much. Hopefully you can now see my slides. And one or two other questions that have come up I might touch upon. I'll try and keep this fairly brief so we can get back to questions after this. And I'm sort of touching on all these points, but none of them in necessarily great depths. So let's just, in case you don't know much about us, we are a multidisciplinary design practice We have research projects stretching back to the 1970s when we developed the ICI Wilton campus, which I know is still in use as a science park now. And the two images on the slide, essentially we've now got on site the AstraZeneca global R&D and headquarters at the Cambridge Biomedical campus. And we've also got on site the Google headquarters at King's Cross with Big and Helwick. So it's quite an interesting sort of range of work. And in addition to the commercial work, there then is a whole bunch of work working with universities right from the inception of the practice in 1961. We've worked with Cambridge delivering 6 science research projects and universities Manchester, Edinburgh, UCL, Warwick, to name a few, as well as some of the public facing bodies such as Glasgow Science Centre and also the British Museum and people like that. So it's a wide range of different stuff. I'm going to talk fairly briefly about our work at the Norwich Research Park. So the project I'm basing this around is the new research facilities for John Innes Centre and the Sainsbury Lab. I'm not planning to really describe the design that we developed, but we've had the opportunity to, having developed a stage 2 design for a good low carbon modern research facility, we were then asked to look at what would it actually take to make it net zero carbon over 25 years, which has allowed us to capture how much further we had to go in order to undertake that aspect of the work. And that's the bit I intend to share with you today. Developed the project with our multidisciplinary team in London. And it comprises 3 key elements. There's the main new laboratory building itself, which is 22,000 square meters. There's a 5,000 square meter refurb element, which is actually the refurbishment of a building we designed over 30 years ago for the same client. And then in addition to that, there's the horticulture facilities, which is both glasshouse and controlled environment rooms, which is a mixture of new build and refurbishment. So there's some quite challenging elements within that. We all know we're facing a climate crisis, and I think the key aspect of what other people have been talking about today is the fact that clearly there is going to be legislation, there is going to be targets, funding bodies are going to start asking more difficult questions about your carbon emissions as owner and landlord and also of your occupiers. The drive has been driven initially by government and response to climate change, but you know the end user client are also going to be developing their needs for this. For the John Innes Centre specifically, the drive to net zero carbon came from the funder, the BBSRC and UKRI, in order to align with government policy and targets that are emerging. So the question was set, how do we make it net zero carbon? What's the impact? How will it impact on science? And how much more will it cost? There's lots of development and information and guidance and targets for net zero homes and offices, but there's very little for laboratories, which is really the question asked just a moment ago. So just to give a definition, net zero is achieved by balancing the amount of carbon gas, CO2 gas emissions introduced into the atmosphere and understanding how that's considered over the whole life cost of the project. The hierarchy we followed is to achieve net zero was firstly to build less, then to reduce the embodied carbon and deal with the fabric issues of the building, and then the operational carbon, and finally look at then with the carbon that is being emitted, how do we deal with that and offset that? And the aim was to do that without looking at third-party offsets. So the aim was to do it entirely locally and therefore achieve what we would consider to be true net zero carbon. So to quantify the required reductions for embodied and operational carbon, we did look at what the industry targets are and those that are being developed. The trajectory was what Debbie really referred to, and that's the graph on the left. I won't go back through that. But it was clear to us that there are no carbon targets for lab buildings, neither operational nor embodied carbon. So we set about looking at the targets that did exist and attempting to work out then how we could extrapolate those for a lab building. So there are targets for healthcare buildings, hospitals, and there are targets for offices. It seemed to us a reasonable starting point to say that a lab building is a bit of a mix of both of those things, and therefore a halfway house of that is a good starting point. We went through our logic with UK Green Building Council and determined that the benchmarks that we were setting for ourselves, a bit like marking our own homework, were reasonable and aligned with the kind of targets that were being delivered across the country. So in terms of reducing the new built element, I mean, obviously, if you don't have to build at all, that's great. But Debbie's already touched on the challenges that come with refurbishing, and I will touch briefly on that in a little bit. I mean, one of the things that comes with reusing existing buildings is the government's VAT rules don't actually help you in that regard, particularly if you're then adding additional buildings to an existing one, because you get stung for the VAT on your new building as well. So there's a lot of challenges around that, which hopefully will be resolved. So the first thing was about reusing what we could. The second part was to look at best practice industry benchmarking to challenge the spatial requirements that were being demanded. And we probably went a little bit further than we would normally have done at RIBA stage 2 for this. But the key way in which we're actually able to reduce the area was the very pragmatic approach the end user client, the occupier, took to how much space was required. Now, I know as landlords and developers of buildings with potentially unknown tenants, that's quite challenging, but actually really looking very hard at how you reduce space is really important. Reducing space obviously is easy, but ensuring that the science activity, the research activity can still be undertaken in that space is much more difficult, and you need to spend a lot of time really looking at that carefully to make it more efficient. Interestingly, it reduces the embodied carbon, it reduces the operational carbon a bit through heating and lighting. What it doesn't do is reduce the operational carbon due to the activity in the building, because you're just making it more intense, you're not actually reducing that activity. And that's a key aspect of looking at the operational carbon. So when we looked into assessing our own design, we're looking at embodied carbon. We're great proponents of a tool called One-Click LCA. We don't own it, it's an independent tool. But what it does enable us to do is take the BIM model that we developed for the design of the building in any case, and evaluate every aspect of that BIM model for construction. So all the materials, all of the structure, both in terms of its what it took to make that material, the transport to get that material to the site, as well as end-of-life reuse. So some materials are easy to reuse, some are not. All of those aspects are covered in the One-Click LCA, and it allows us to identify the embodied carbon associated with all the materials that we're proposing for the building. When we were looking at that and trying to determine whether we can go further than our kind of already good practice design, we looked quite carefully at all of the materials, and there were some aspects that just had a greater impact than others. So structure has a greater impact. M&E is very difficult to, at an early stage, really reduce the carbon impact of in terms of the actual materials, the embodied carbon materials, but that will come in later stages. But things like roof, walls, facades, and superstructure are key aspects. But part of the issue with that, of course, is then working out, well, does it have other cost impacts? So we moved from brick to timber for the main facades, which has some questions around longevity, some questions about maintenance. And so we considered all those things when looking at it to make sure that the cost and the carbon benefit was properly matched. Same was true of windows. In the lab, we had a not untypical aluminium framed window system. When we looked at going to an engineered timber system, the reality of the maintenance involved in that and the potential risk to air leakage if the timber were to warp just meant that we didn't feel it was the right approach. So there's always other aspects to consider when looking at the carbon situation. The lowest carbon material is not necessarily the best material overall. One critical aspect, particularly with labs, is very much how you deliver the superstructure of the labs. Some of the technical aspects, particularly vibration, some of the fire aspects to do with lab design, some of the contamination and cleanliness aspects to do with lab design, sometimes mitigate against particular materials. We had ended up with a concrete structure for the lab when we originally designed it to our stage 2 design. But what we did in the subsequent piece of work was really properly investigate with the client the possibility of moving to a timber superstructure. In reality, it wasn't possible everywhere to do that. And also in reality, it wasn't possible to move to an entirely timber construction because the vibration performance of that timber construction is just simply not good enough for a lab. But by looking at how we develop zones of higher vibration performance around the cores, increasing the stiffness of the timber construction by using a timber concrete hybrid and increasing the amount of lab that was on the ground floor area, we were able to come up with a solution that the client was comfortable would meet their needs, but was a much, much lower carbon impact. The range of available building materials is in itself interesting when looking at embodied carbon. The reality is that many of them are either significantly higher cost and therefore potentially out of reach, many of them are also simply not tested in the UK climate. There's some really interesting low carbon materials using innovative bio-based materials such as preformed mycelium panels. They're kind of a fungus. But they're not really well tested yet in the UK climate. They're tested much more in a lot in Australia at the moment, but not so much here. So all of those things were part of what we assessed when we looked at it. And most importantly, we worked closely with ACOM, who are our cost consultants, to plot a chart to understand the carbon benefit against the cost impact in order to determine which of the materials we thought were worth taking forward into the next stage. On the operational carbon front, we'd gone quite a long way to developing a low energy building as part of the stage 2. So the question really was, well, what could we do to improve on that? Like many sites, like many science parks, JIC and the Norwich Research Park have a very effective gas-fired combined heating and power plants, which they use to provide heat, but is also providing with very, very cheap electricity because the gas price is so low currently, which is likely to change. And key to achieving net zero carbon is the reduction or elimination of gas powered energy from the site. It's not only carbon intensive, it's also relatively inefficient. As you can see from the graphs that are on that chart, it isn't possible always to eliminate gas entirely. So on this project, the glass houses require a small quad-gen combined cooling heat and power plant, but we hope to capture the CO2 from that and use that for the scientific horticultural purposes. Other than that, everything is powered through air source heat pumps, which is a far more cost-effective approach than ground source heat pumps, but as Debbie was saying, does require quite careful concern around the performance of the building fabric. So the graph on the left here shows where that operational carbon saving was made. What you can see is actually taking the new build element, because it was already performing very well, the reality was there wasn't very much further to go, and the reductions that we achieved there were mostly down to area reduction rather than actual operational carbon energy reduction. However, in the refurbishment element of the project, where we were looking at the existing building, we had originally tried to do as little to that building in order to spend as little money on it as possible to make it useful, but also to try not to touch it too much and get involved in major works to it. When looking at it again, the significant carbon savings, although those are slightly increased embodied carbon, came from completely replacing the plant, moving away from the gas-fired boilers to air source heat pumps, but doing so by looking at the more poorly performing parts of the facade and replacing those. So we didn't replace everything. The brickwork facades were performing reasonably well, but the aluminium cladding and glazing were really poor performing, and actually replacing those made a massive difference. When it came to the glass houses, much of that reduction, again, is to do with area reduction, working really carefully at how much space they really need to create, but also looking again at how we can reduce the gas from the use there. Another key aspect, which does come on to where your tenants can help in this, is the selection of equipment. The controlled environment rooms that they were utilising, the manufacturers weren't necessarily focusing on their low energy approach. Another manufacturer had a much better performing controlled environment room, and by moving to them, we've reduced a huge amount of energy demand. So kind of how we did in terms of the performance of that in relation to how we thought we would do at the outset of that was quite surprising. And these two graphs take a little bit of explaining. So on the left, you can see we did better than we thought we were going to in reducing operational and embodied carbon, but also it seemed to come at a lower cost than we expected. And I think that's quite interesting, because some of the aspects that I've talked about and the idea of trying to reduce the amount of area and building that you're creating has a really key aspect, because then there's the opportunity to afford to pay for some of the increased costs, with the increased cost of material, the increased cost of structure, and balance that need. So that focus on driving down spatial demand is a key aspect, regardless of how you approach this to driving down carbon. It did require an awful lot more work at stage 2 than we might normally do. And so I think there is an aspect of this where you've got to bring forward some of the elements that you might do later in the project. One key aspect of that, and Debbie talked about the way that buildings perform in design and how they perform in use. We brought forward the TM54 analysis of the building activities in order to give us a proper sense of how the building will perform in use, which is really looking at and determining the load and plug loads and equipment loads and the actual science activity rather than just the building activity. What that actually determined is that the loads for the baseline building would have been much higher than we'd expected, which I think reflects what Debbie was talking about once you factored in the activity loads that come with equipment. And then the key driver on the embodied carbon was the ability to move to a timber structure. And that really was driven by the ability to have a conversation with the users about the technical requirements they really needed to deliver in this building, and focusing on reducing those where they weren't required, so that we could really kind of drive down the carbon intensity of the embodied carbon of the building. So the last aspect of the carbon equation, I'm just going to talk briefly a little bit after this about health and well-being, is then, okay, so we've got to the lowest we think we can get to in terms of embodied and operational carbon. Now, what Debbie was talking about is how then you deal with that if you sort of want to become carbon neutral and take your energy from a zero carbon supplier. The target here was net carbon zero over 25 years. And there are lots of different ways you can look at that through offsetting. There are offsetting schemes both in the UK and abroad. They are an approach to getting net zero carbon. They would get the tick in the box and the certificate. We and our client believe that that's not necessarily going to achieve true net zero carbon, because you really need to be generating the energy you're using through net zero carbon moves additionally to the grid. And that's the key point that Debbie touched on. So because of the nature of the site in Norwich, happily there's a lot of land locally nearby that we could consider for use for a fairly large PV array. And I think this is another aspect that's relevant again to your science parks, is the question, well, your tenants could put renewable energy generating solutions on the buildings that they're renting from you, but it's way bigger than you can fit on a roof. And I think that's the scale of these things is worth considering. And it becomes something that you might consider as a science park owner, manager, as something you deliver to your tenants and clients. And one of the reasons for that is delivering your own PV array has the significant benefit. You're then in control of your electrical costs because you're no longer drawing it from the grid. So although the cost that we identified for the PV array was 32 million, so it's a significant capital cost in this instance. The energy savings against the cost of buying electricity from the grid was 50 million. So there's a net saving of 18 million from generating electricity, and that's not to be sniffed at. I've got a few more minutes. I'm just going to go through the other things that are worth talking about beyond net zero carbon in terms of sustainability. And Carl talked about a few of those things at the beginning session. It's very easy to forget about these things in the rush to net zero carbon, and all of the targets are going to be focused around that because that's government policy. But the other aspects from health and well-being, the well certification schemes, and the other ones that also look at health and well-being, we've gathered those together. These are things that we look at in all of our projects. I'm not going to try and go through all of those now, simply for pressure of time, but there's just a couple of things I thought were worth bringing out of recent projects that touched on a few of these that might be helpful and relevant to you when you're developing and refurbishing buildings in your stock. So the first aspect of this touched on healthy places to work. And again, Carl mentioned this in his session at the beginning. The materials we build our buildings out of, not only do they need to be low embodied carbon and have the ability to be reused at the end of life, they do have the ability to actually be potentially harmful in themselves. We were working with one of the global tech giants, I've mentioned them already today, but I'm not allowed to name them again in this context, where they were very concerned to ensure that we were delivering a building that was properly healthy for the staff and the people who were working in it. So as part of that project, we worked with them to develop our own internal red list of material constituents, substances that we were not prepared to be existing in our specifications. So we've always specifying materials and products with these chemicals and with these substances in them. But it took quite a bit of research because there's a lot of data about this sort of thing. Happily, there are a lot of bodies looking at it. Most specifically, and probably the most useful, is what was previously the EU and now the UK registration, evaluation, authorization and restriction of chemical lists, the REACH lists, which are regularly updated. So we take those as our starting point, and then we work with our suppliers before we write our specifications. We send them out our own bespoke questionnaire. They self-certify to some extent what their products contain, because it's not like a food stuff. You don't get an ingredients list on the side of the box. And on the back of that, we then make our specifications based on that to try to ensure as far as possible we're not specifying harmful materials. That in itself is a hard enough task. The reality of building processes is that we then need to track that throughout the entire construction process. And in theory, it would be good if our building occupiers then tracks that through their refurbishment and reorganisation processes. Because every time a material changes or is substituted or a contractor comes with an alternative, we need to go back through that process, go back through the testing regime, understand whether those materials actually are containing the sort of materials and substances that potentially put harmful gases, off-gassing into the air, volatile organic compounds, all the things we know we shouldn't have in the air and are damaging to our health and a part of the health and well-being of your tenants. Another key aspect that I think you as science park owners, developers can look at and consider what your offer is to your tenants is the other aspects of health and well-being, partly building communities, which I know is a focus for many of you, building activities and opportunities to really hit all of these sort of 10 targets under the health and well-being and the WELL standards. The project illustrated here is the Bright Building at Exeter Science Park, which we developed with Bruntwood. It's a multi-use hub building, serves all tenants of the park, and it pretty much manages to touch on all of the sustainable target areas. And it does raise questions about what park owners and operators can do to support the health and well-being of their tenants and to provide some form of sustainable support systems for innovation campus and science parks. And this approach continues beyond the building into the master plans and the landscapes. These sort of settings, these landscape spaces, they're not only nice settings to buildings, but if they're appropriately designed, thought about and specified, then they become the setting for activities and events which can be managed by the park owners and users to create the kind of collaborative social events and activities throughout the year that build community and increase the mental health and well-being of the tenants of the park, and overall, in theory, should improve everybody's experience of work. So finally, the last slide, the last bit about this is then it's all very well sort of doing these things on a project by project basis, but the reality is all of our projects, all the work we do collectively needs to be focusing on how do we achieve net zero carbon or go further? How do we ensure that health and well-being become the industry standard for all projects that we're involved in and that are being developed? So we started as a practice gathering together net zero case studies, good case studies in health and well-being, a range of different scales. From that, we're setting out the project processes and developing a series of checklists as part of our net zero toolkit to sit alongside our burgeoning library of low carbon healthy materials to help all of the design teams within our practice to make good decisions about how we develop designs and how we build buildings. We're now, the next stage of that process is to understand how we can really embed all of those aspects, including the one-click LCA process and the health and well-being standards into our BIM processes, so the BIM model development. All of which is sort of continuing at a pace. We have a plug-in for the one-click LCA, which means that as we develop the building designs, we can check the embodied carbon of every material we specify. We can check and test different options, understand how they impact the embodied carbon, and more especially understand which of those materials are easy to reuse at the end of life in order to ensure that all of our buildings have a life beyond that of the building itself and the occupiers who are there. So just to draw things and conclude, the key aspects, it seems to me, that have come out of this is there's more detailed work required in early stages to develop both a better understanding of the building itself, what it needs to be, how flexible it can be, how low embodied carbon can it be, what the technical requirements are, and also to some extent a better understanding of tenant requirements within that building to drive down to achieving net zero carbon across projects. And I think as owners and landlords, a focus on what you build and how the health and well-being of your tenants can be supported by both the buildings and the landscape and the materials that you use, as well as kind of the potential for investigating the delivery of low and zero carbon energy supply within your science parks or nearby to your science parks, both either PV, wind, ground source, air source, heat pumps at scale, or even biofuel CHP, such as at Nottingham, as a way of your offer to your tenants to help them in their quests to also achieve net zero carbon. Thank you.
Brilliant. Thank you very much, Keith. That was very interesting, very comprehensive, I think. Not too many questions directly for you, which probably means you've covered everything. We do have one. Richard Walders asked, he mentioned you touched on this, but How much of a part do you think that lab equipment manufacturers have to play in reducing energy consumption of buildings?
Absolutely, and it's a really interesting question. This we were looking at some hospital designs recently where they were asking us, well, how do we kind of manage this net zero carbon approach? And the question came up really quickly on that, which I think is equally applicable to research parks and research buildings, is if you had two pieces of equipment and one was 10% better at saving lives than the other, but was slightly worse from a carbon point of view, you would still go for the piece of equipment that was saving lives, because that's the purpose, that's what you do. The same is true in research buildings. So there is definitely an element that you've got to have the right equipment to do the work you've got to do, and that will have a carbon impact. That said, it's undoubtedly true that a lot of the equipment manufacturers are behind the curve on this, and the energy demand that goes with some the very typical science equipment is way higher than it should be. And as Debbie was alluding to previously, both not only the energy demand of that equipment, but also the way it's used in buildings and being properly used and turned off and being on standby duty rather than being full duty. All those sort of things have a massive impact on that. One of the things that I'm quite interested in, and we're starting to try to do in the practice, is understand how do we really properly measure that, because Debbie talked about BMS, information, how you can track the energy use. It still doesn't actually tell you whether that energy use is really reflecting the activity in the building. And that I think is the next thing for anybody to be looking at, to understand, how does that equipment use, people use, and energy demand of the building really go together?
Yeah, I think absolutely. I think bringing Debbie back into conversation as well. I mean, I think there's been quite a few comments in the chat, and certainly something I've been thinking of in terms of the effect of COVID and people returning to work, but potentially in smaller numbers or for less time, is what's going to be the impact on buildings where they're potentially unoccupied for large parts of the day, or randomly occupied, and how do we manage and measure that?
Yeah, sure. Do you want me to just pick that up? I think going forward, that was a good point from Keith as well, that what we're seeing in terms of monitoring whether a building's performing, we've got to get data from a number of different sources. So we're getting data from the BMS on temperatures and whatever sensors they've got in the building. We're getting data from meters, sometimes directly, sometimes not. We're also getting data from occupancy sensors on the lighting and cameras, and then also the entrance hall, when you have a swipe cards and everything. And it's about trying to work out who's in the building, what the temperature outside and inside is, feeding that back through the design model. Typically when we're doing buildings, we're using IS or TAS, put that back through the model to get a real-time energy target, and then looking at the meter to say how much energy is going through it. Then you can exception report, create alarms when it's using too much energy. The next really clever bit of intelligence, although I don't like the word artificial intelligence, is can you then determine from the temperatures that are alarming, or the meters that are alarming, or the sequence of events going on, can you send the user a very simple message to say, we think you've left this bit of equipment on last night, go and turn it off, or go and adjust temperature sensor 9, which is under the staircase 3A, and change it to such and such. In theory, through the BIM model, you can then even show somebody a picture of where it is, what it looks like, give them the instructions too. So the future, I think, is definitely with buildings that are much more user-friendly. And we've got to use the IT to do that for us, rather than make it just more complicated with loads of IT in it. But sensors and monitoring buildings are the key, because then when it's not occupied as much, you can make sure you're only using the right amount of fresh air. People who've left their air handling units on all night when the building's empty, why? Nobody wants fresh air during the night. And another really interesting question I've seen in the chat is about, do you use opening windows or do you use mechanical vent? And it's a debate that's going on, and I suspect it will be horses for courses in the end, that if you've got a building with opening windows and it's not a high value building and you've still got to achieve this net zero carbon target, you could achieve that by opening the windows for the majority of the year, having a little bit of heating, and you might hit the target if you don't want to refurb it. If you're refurbing it, the ideal is always to make it airtight and ventilate right, is the principle. So a lot of schools we're building, for instance, will meet the passive house standard, the German standard. And also, even if you don't want to achieve passive house, you've still got to achieve the airtightness and do the ventilation correctly, using mechanical vent with heat recovery. So although you're using a bit more energy in actually moving the air around the building, you're actually using the extract air to heat the incoming air, or vice versa in the summer. So you're being quite efficient with your use of that piece of energy, really. And you're not letting pollutants in from outside. And you're not relying on occupants to open and shut windows when it might be raining or suddenly changing in weather.
Or keeping burglars out.
Or keeping burglars out. Yeah, there's lots of vents and bars going on to schools and mechanical vent overnight. And yeah.
Brilliant. There was a question earlier on, actually, which was directed at Carl that we didn't get to, but I think probably, you know, for all the panel to think about and answer, which was, and really touching on a point that you made, Debbie, about getting landlords to kind of proactively engage with prospective tenants around ensuring that the BREEAM or LEED standards that they're sort of embraced and maximised. And how do you see that working? How do you see that relationship between the tenant and the contractors working?
It's a really good question. And we just held a British Council of Offices seminar, which said, I think the challenge was, is regulation the only way we'll have net zero carbon buildings? So it's been difficult in BREEAM alone to make sure a tenant fit out meets the BREEAM requirements to get the landlord's BREEAM certificate. But BREEAM is, as I say, a design standard, and it's not about an operational standard. There are a number of landlords who I'm still in contact with from the LNG days who are trying to work through the Better Building Partnership to talk about, can we get green leases or memorandum of understanding with our tenants that says they will commit to using this amount of energy. And pretty unsuccessfully, as Carl said, you know, we've tried it for years before, and even on sharing data, didn't really work unless somebody was super keen. When it now gets into cost, so who's going to pay the cost? Say there's a carbon penalty if you use more than 55 kilowatts. Who's going to pay the cost, the landlord or the tenant? What if the air conditioning you're using more energy than the landlord said it was? Who's going to prove that? And trying to get landlords' interests and tenants' interests aligned when there's costs involved to get to the right aim is just not. Nobody knows yet. I've talked to quite a few lawyers as well. Nobody knows of a lease that has bound the tenant in. The interesting thing is that in Australia, it works the other way around. They have something called NABERS, NABERS, which is coming into the UK. And it's a building energy rating scheme, the last few letters. And you have a rating in design, you have a 4 or 5 star. And then if that building doesn't operate to that 4 or 5 star rating in operation, the landlord has to rebate the tenant money. So the landlord has a rating on the landlord services, the tenant has a rating on the tenant services, and each other can then rebate, you know, has to rebate the other. It started because the Australian government was a predominant office tenant in Australia, and they could almost push it through. It's coming into the UK, but there isn't that predominant tenant who can actually push for it. Landlords still have the, you know, the upper hand in this. So yeah, I'm not sure it will happen without regulation personally.
Okay, interesting. Keith, did you have anything to add to that?
No, I don't think so. And I think that the interesting thing about that is this kind of dilemma then science parks, particularly of not knowing how your buildings are going to be used, and therefore how can you kind of reach a net zero carbon if you just simply don't have that key piece of information, which is why I think, you know, the energy generation part of that is potentially an interesting thing from a science park perspective, not least because there's quite often a lot of land around that could be used around the parks, and that is a way of then kind of filling the gap between the expected use and the actual use as tenants change.
Interesting. We've got one very specific question for Debbie from Paul Owen, who said he was loving the presentation. He was asking a selfish question about the part that reduction in water usage plays in CRE sustainability plans. Do you have any thoughts on that?
Yeah, I mean, it's important. All the aspects that I put up earlier are all important. It's not just carbon and energy we have to focus on. In the corporate real estate sector, Most of the landlords fill in a survey every year called GRESB. It's the bane of everybody's life. It's the global real estate sustainability benchmark. And investors use this all around the world to determine how green and sustainable the funds are. And what this survey has moved over to in the last few years is it's gone from asking about policies and processes and commitments into data. And it asks for not only carbon data, it asks for water data. And slowly they ramp up the scoring for good points for water efficiency. So yes, it is important. As ISG, one of our corporate policies also sets our own water targets. So we have got a trajectory to get our own water uses down, both within our own offices, but also within our sites, our building sites. You know, the big challenge is, can we build without using water? Which makes all our subcontractors laugh at me, and I'm like, you know, just think about it, guys, you know, innovate with us. And we're lucky we've got a really good trusted group of subcontractors who are looking to innovate, because all the construction equipment we use has got to be electric going forward. We can't use diesel on site, so, and it doesn't exist at the moment. So, you know, people like Cat and everybody haven't developed it, and they've still got prototypes. So massive challenge on both energy and water, I think, going forward.
Mm-hmm. Okay, one more specific question, and then we'll close off with a kind of general wrap up. But Josh was asking earlier on about, so one of his sites is a former World War II airbase, and bringing these up to ABC B by 2030 will be incredibly difficult and hard to justify the payback. So I was wanting to know where you would stand on buildings like that.
I'll kick off and hand it over to Keith, but it's not about payback. If you can't let your building, what are you going to do with it? It will be an empty, stranded asset. It will have no value, and nobody will want to buy it. So just like when F&G rated EPCs came in, and when I was at Legal & General, we sold a lot that we knew we couldn't upgrade very well, very easily. It's about your asset. There is an online toolkit called CREM, which has been developed, and you put in the characteristics of your building and its energy use, and investors are using it to see whether your assets will be stranded in the future and whether they're going to invest in them going forward. So it's not about a payback. It's about you know, the fact we have to do it. It will be regulated, and you know, you don't want to be left with this asset that you can't upgrade. I don't know if Keith's got any thoughts.
No, I do. Just to add, I mean, I think there's an element of that. There's also the fact that it will become more and more expensive to operate as, you know, gas prices go up, electricity prices go up. You know, the funding that goes with the tenants who come into your building, you know, that will all become challenging. So the payback will change over time. That said, I think the key to that kind of building is targeting where the investment is actually made. You know, I think it'd be worthwhile kind of looking at each of those buildings in really detailed manner, understanding which of the construction elements actually potentially could be upgraded to perform, or even could perform quite well as they are, and then really focus on those bits that are poorly performing within that individual building and replace those.
Brilliant. Okay, so just to wrap up then, in a minute, I guess, each of you, what would you say are the key challenges with delivering a net zero carbon research building in particular?
I'll let Debbie think for a little bit on that one. I think the key challenges to some extent is the one we've touched on a couple of times already, which is about it. You have to have both the end user aspect of it and the design aspect of it. It's both the building provision and the activity that goes on in the building that actually allows you to reach net zero carbon. So you've got to have proper engagement, good engagement with your tenants that enables you to kind of work out how collectively you reach that target, because you can't do it with only one or other looking at it.
Yeah, and for me, I think it's about getting our building modelling a lot more accurate. One of the buildings I'm monitoring, you know, we used a well-known M&E consultant to model the energy use of the building. But when you're trying to use IES and TAS to model labs and look at the heat loads and the air conditioning, it's an absolute nightmare. So for science parks and labs particularly, it's getting the modelling accurate and then thinking about, even if the building itself is going to operate to net zero, the time you put in all your equipment and what we call the process load, how are you going to offset that? Because that will have a trajectory. It will have its own science-based target. Depending on what sector you're in, you will have a trajectory to get to. So your equipment manufacturers are going to have to get more efficient. But how do you marry that with the building? So it's about understanding buildings so that we can at least try and operate them to net zero, I would say. It's probably more than a minute, that.
No, that's perfect. Very succinct. Okay, brilliant. So we've come to the end of our time. So we're slightly overrun, but I think that's really good. Lots of interesting questions, and I'm sure lots more that will come up as a result of this. So it just falls to me to thank our speakers. So to thank Carl and Debbie and Keith. Very interesting presentations. Thank you to you, the attendees, for joining us today and for interacting with us. That's really appreciated. Also, massive thanks as always to the UKSPA team for organising these webinars. So thank you to Jim and Adrian and Louise. It's been fantastic. I think as Adrian's mentioned in the chat, the recording of the webinar and the presentations will be available on the UKSPA website later on today. So if you go to ukspa.org.uk, you should be able to find those. And then just to mention as a bit of a plug, today's webinar is part of an ongoing program of webinars from UKSPA. So the next one, which will be very interesting for me certainly, virtual tenancies, process, compliance and opportunities. And that's taking place next Thursday, 29th of July, same time, 12 noon until 1:15. So please go to the UKSPA website to register for that. Once again, thank you again for continued support. It's really, really greatly appreciated. And I look forward to having one of these in person at some point in the near future, all things being equal. So thank you all, and I'll say goodbye. Thank you.
Thanks very much. Bye, everyone.